All right, so that is the what I just finished was what Aristophanes had discovered, um, and so he figured out the pretty good accuracy the size of the Earth. He also or estimated distances to the sun and the moon um, using this information. Uh, yeah, I mean, it wasn't that accurate, but that's fine. So this is another picture of what happened. Here's the rays of sun. It turns out that Syene is right on the Tropic of Capricorn, and so on the first day of summer, the sun is right overhead, and so that's why there's no shadow along in the well, and the sun shines directly down, but there's a 7-degree shadow in let's say a stick standing straight up, or an obelisk in this case, which there are plenty of them in Alexandria. And so Aristophanes measured this. He measured what the angle was. They were very good at that, and then worked out um, if that's 7 degrees. He figured out what the circumference of the Earth was. All right, so let's see. Now, here's something that really confused the Greeks for a long, long time. If you watch the planets over periods of time, I want to emphasize this. This did not happen in a single night. If you can watch the planets, and they will move from east to west with the stars, right? Just like the stars, they will move from east towards the west. Now, that of course is just simply the rotating Earth, right? That's the Earth rotating counterclockwise around the sun, as do most objects going around the sun in our solar system. Of course, the Greeks didn't know that necessarily, and you always find the planets are relatively close to the ecliptic. They follow remember, the ecliptic is the path of the sun in the sky, and the through the constellations of the zodiac, which of course we know now there are really 13 constellations of the zodiac, as I mentioned before. The ecliptic passes through all 13 of them, and the planets are not very far from those. So, for example, you never see a planet near Polaris, the North Star, right? It's always near the stars of in the constellations of the zodiac. That's where the planets are located. All right, so back during the time of the Greeks, of course, it was just the planets that were visible to the naked eye. Okay, so humans can see without a telescope or binoculars. We can see Mercury and Venus. Of course, Venus is very easy to see. It's one of the brightest objects besides the moon in the night sky. Mars is very visible. Mars has a particularly reddish, more of an orangish color. Jupiter and Saturn. All right, so that was pretty much it as far as the planets go. And because of Aristotle, people of the time, except for somebody like Aristarchus, they believed, like Aristotle did, that the planets go around, and including the sun goes around the Earth. That the Earth was the center, and we'll talk about that in a little bit. All right, so just keep that in mind. But really, the motion of the planets is what's important here, right? So if we look again, the planets in one particular night or 2 nights, the planets are moving just like the night sky from east to the west, but that's the rotating Earth. All right, now it gets a little bit more complicated, and it got a little bit more complicated for the Greeks as well. And the Greeks really struggled to explain this. Okay, so remember, humans started, recording where the planets were over time, and so if you watch the planets, especially relatively close ones to Earth like Mars and Venus, if you watch them over months, like several months, you'll notice some things that happen uh, with the planets that the stars don't do. Remember, the stars are so far away from us; they're more or less fixed. Well, they are. They're fixed with respect to each other. They don't move around. That motion is just, of course, that east to westerly motion is just the motion of the night sky because of the rotating Earth. All right. So now this is something that people noticed for if you, and this is true for all the planets. All the planets do this. By the way, the sun and the moon do not do this, as you can imagine. Well, because of the explanation of why this happens. All right. So let's say we'll pick on Mars here because Mars is a very easy one. And as Mars is this is the constellation Scorpio. Um, oh, actually, is that Scorpio? But it doesn't matter what constellation it is. At any rate, yeah, actually, that is Scorpio. Anyhow, so as you watch Mars over several months, right? So this is, for example, in February of 2016. Mars is right here with respect to the stars, and then Mars is creeping towards, towards the east. And the planets do this normally. They will start to move towards. They will move with respect to the. So what I'm talking about is over several weeks to months, the planets will move with respect to the background stars. All right. In fact, the planets moving is really why they get the name planets. I mean, the Greeks didn't really know what the heck they were. They just called them planets, which is the Greek word for wanderer. They wander throughout the night sky. Now, again, it's not over a single night. It's over the course of several months or weeks to months. Many weeks to months. You can see this. All right. So this is just an example. So Mars moves east, and then there comes a time where Mars just suddenly, without explanation, starts to go backwards. That is, it starts a westward motion across the sky, and we call that retrograde motion. That's a very important name, the retrograde motion. Retrograde and westward motion mean the same thing for the planets. All right, so only the planets do this, right? Only the planets, and of course, since then we've discovered Uranus and Neptune, and they undergo retrograde motion as well. Of course, you need a telescope to be able to see that, but anyhow, it's going back to the time of the Greeks. They saw this retrograde motion, and so over the course of several weeks to a month or so, depending on what planet it is and where it is in its orbit, it will start to move to the west. Remember, again, it's with respect to the background stars. So, like Antares is a really bright star, right? And so you can compare Mars's position to Antares. And you see, it's moving. It's getting closer and closer and closer to Antares. Then it moves, and of course that would mean it's moving to the east. Here it's moving to the west, and then it stops for some reason and moves to the east again. All right. So notice this is from February 16 to September 8th of 2016. So it's taking months and months for this to happen. It does not. You don't see this. And by the way, this zigzag motion is observed. Sometimes it's actually kind of a circle that it makes. But anytime it's moving backwards, that is westward, we say that it's moving in retrograde motion. There's Saturn doing the same thing. I mean, all the planets do this. You find it in different portions of their orbit. All right. So again, the Greeks had this geocentric model. That is, that the Earth was the center of the entire. Well, for them, it was the entire universe, and which, of course, is part of that's the solar system for them. Um, well, they didn't really distinguish between the solar system and the universe, but we'll do that a little bit as time goes on. So there's this thing called the geocentric model that was established by Aristotle, and he wrote about it. He was a really influential person, and this gets adopted by cultures throughout the Middle Ages and right down into the Renaissance. All right, so there was a couple of people that are of importance to us. This guy Eudoxus was one of the Greeks. What we credit him with is proposing the geocentric model, and of course, remember the Greeks kind of borrowed from each other. So I would imagine that Aristotle found out about what this guy had said and just kind of adopted it as his own. And he also came up with the model of the celestial sphere. The faster objects would move in the sky, and the smaller it was on the corresponding. Yeah, he imagined these different spheres around the Earth, and so he comes up with this geocentric model. But the problem is the geocentric model cannot explain retrograde motion at all. All right, it doesn't work very well. So this is kind of the view of the you imagine the celestial sphere all the way around. That's where the stars are. Remember, the Greeks didn't think about the stars at different distances from each other. The nearest thing to the Earth is the moon, because that moves fastest in the sky. Then comes Mercury and Venus. This has to do with just looking out at the night sky. Then the sun is in its own sphere, and so forth. Right? Then comes Mars, Jupiter, and Saturn, and that's it. Those are all the things that were visible. Again, the sun never undergoes retrograde motion, and neither does the moon. Which, of course, if you're trying to come up with an idea that explains the motions in the heavens, which is what the Greeks ultimately were trying to do, it doesn't help. When two of the prominent objects do not undergo retrograde motion. So how do you explain why is it that these other things do? All right. So now we fast forward to I forget exactly when Ptolemy lives. I think it's like so it's around the time of the Romans. So maybe about 100 years past the time of Christ. Just for as far as anyhow, he also just like Aristophanes before him lived in Alexandria, and he comes up with this idea. And here's the thing: the idea, even though it's wrong, it actually works pretty well for naked eye observations. And his idea was that the planets would move in their own little circles, and so there's times when you look out from the Earth and the planet seems to be moving backwards. That is, to the west, and then it moves to the east, and the whole thing is it's kind of like a spirograph if you ever had that as a kid.